Hi guys, welcome back. So in this video, I'm going to show you another example of simplifying a trig function. This time we are going to be doing a little bit more challenging than the previous two that we have done prior to this video. Okay, so let us look at this particular trig function and then we'll see how to simplify this. So I have a trig function which looks like this. This is my example 3. I have sine x plus cosecant x. We already know that the sine and cosecant are the reciprocals of each other. And then we have sine square x plus cosecant square x and minus 1. Okay. Guys, we want to simplify this. So before we try to use the trig identities, I think the first step that we should do is what we would ideally do for if it was an algebraic expression, which is distributing. Okay. So we'll start with this term, multiply through with all the 3 terms here, and then we're going to do the same thing with this term as well, right? So we're still following the rules and skills and things that we have learned in algebra. Instead of working with the algebraic functions or expressions, we are working with trig expressions. So let's see what we get here. Sine x times sine square x. So that will give me sine cube x, right? Then what is the next one? Then I have to multiply this by this. So I'm just going to write it plus sine x times cosecant square x. That is the second term. Then third term would be sine x times negative 1, which would be what? Which would be negative sine x. Right? So far so good. Now what we have, we are done with the sine. Now let's go to the second one, the cosecant. So with cosecant, I'm going to write plus cosecant x times sine square x. We are not really using any trig identity so far. We are just distributing carefully. And then there's a plus. There's a plus cosecant x times cosecant square. Guys, there's going to be a lot of terms, so please do it carefully. And then finally, I have cosecant x times negative 1, which is negative cosecant x. Okay, I think I have multiplied all of these, and now I have 6. We have 6 terms, right? Okay. Let us make sure we have everything right. Okay, here cosecant x times cosecant square x is supposed to be cosecant cube x. So I'm sorry about that. Okay, now let's see if we can simplify this any further. So once we did the distribution piece, we have a big expression like this. Now we go back to the to our formula stuff, the formula sheet, and see if we can replace some values. Guys, here we may not be able to really use this anything from here, but we already know that, and let me put it here anyway. So we know that cosecant theta is 1 over sine theta, and let us also put the secant. The secant is 1 over cosine. Okay, that should already be on your formula sheets. So let us see if we can use these to simplify. So sine cube x, gonna leave it like this. Guys, here I can, well, it's up to you which one, what you want to do. Like I'm going to use the sine x as 1 over cosecant. Guys, if cosecant is the reciprocal of sine, then sine is the reciprocal of cosecant. So this formula can also be written as, if I have to solve for sine, simply by this identity, sine will be 1 over cosecant. That is the whole idea of being reciprocal. Okay? So sine x is 1 over cosecant. Then I have times cosecant square x, right? Then I'm going to leave minus sine x like that. Okay, not going to worry about that right now. Let's see where we are heading. Then plus. Guys, this here I'm going to replace this cosecant x by 1 over sine. And then I have times sine square. I don't want to convert both, so I just want to convert one of them so that there may be a possibility of crossing out some things. Okay? And then there's a plus cosecant cube x I'm not going to do anything about with that. We're going to leave it like this. It's already too much because there's a cube here, and then minus cosecant x. Okay, guys, this example is a lot of work, and that's the reason why I chose to do this one. Okay, guys, let us see if we can still simplify it further. Now we have sine cube x. Then this and this, one of these goes away, right? Guys, look carefully. There's a 1 over cosecant, there's a cosecant squared. So one of them is going to go away. So it's plus cosecant x, then minus sine x. Nothing, we're not going to do anything with that. Then guys, here again, we have a sine square x upstairs and a sine x downstairs. So one of the signs will cross out. So I'm going to be left with sine x. And then there's a plus cosecant cube x, and then minus cosecant x. Guys, sometimes you just have to use identities, put them back, simplify things, and then sometimes you will see like things will simplify on their own. So now let us look at this expression again. I have a plus cosecant x, and then I have a minus cosecant x. This and this will cross out, combining like terms. Negative sine x and positive sine x. So see, the 4 terms are gone. And what am I left with? I'm left with sine cube x plus cosecant cube x. And we don't want to really like use any of the formulas to simplify this. I mean, it is simplified enough. Okay. And I mean, guys, one may think that one could like actually replace sine x by 1 over cosecant, or cosecant by 1 over sine, and simplify one step further or something. That is fine, you can do that, but I mean, this is good enough for us. And that is one of the reasons why I'm not a big fan of just simplifying these expressions. I need to see something on the right hand side so that I know what am I trying to make this left hand side look like. Okay. Later, of course, I'm going to do a lot of these verifying, proving identities, where we'll have the left hand side and the right hand side, and we will be most of the times working with one of the sides, whether it's the left hand side or the right hand side, and make it look like the other side. Okay. So guys, that's example 3. In my next video, we're going to talk about some other examples involving trig identities and using trig identities to simplify trig expressions. Okay, and in all these videos, I'm going to try to do many different types so that you have enough examples for you to practice or do your homeworks, or in general, like practice more of these problems.